Right, good day, upper fives. We are carrying on with solving cubic equations. Up to now, the cubics that you've solved, you've had rational solutions. In other words, okay, normal fractions or no irrational numbers, no imaginary numbers or non-real solutions. Now we're going to look at cubic equations with irrational and non-real solutions. You should have your worksheet for this session, cubic equations with irrational and non-real solutions, or you can just listen and print it out when you get back to school. Righty, let us go then. And let me share the screen over there. Okay. Right. So, cubic equations with irrational. An irrational number that we're concerned with here is something like a third. So if you get root 5, okay, those are the irrationals we're looking at in this case, okay, or root 10 or something like that. And non-real solutions is complex numbers with an imaginary part which is not 0. Okay. So your method for, as it says in your notes, your method for solving these cubics is initially, no matter which method you're using, it's exactly the same as cubics with rational solutions, which is what? First of all, you find the first solution by trial and error, okay, of substituting, and to do that, okay, so you're going to say what? You're going to look at the constant term, you're going to write down what the factors of the constant term. I would always start with 1 and then minus 1, etc. Sub those in, okay, so you're substituting in factors of the constant term. And then say you got x is equal to a as a solution, then x minus a would be a factor. Okay, so another of the initial cubic equation. In other words, if x is equal to 2 as a solution, in other words, it gave you an answer of 0, you're looking for an answer of 0, then x minus 2 would be a factor. If x is equal to minus 1 was a solution, okay, then x minus a means opposite sign. So if x is equal to minus 1 is a solution, then x plus 1 is a factor. And then you'll have one factor, okay, and a linear times what's going to give you a cubic. A linear times a quadratic will give you a cubic equation. So to find the other factor is going to be a quadratic factor. And we'll go through some now. To find the quadratic factor, you find the first and the last terms by inspection. And you find the middle term, okay, in other words, the thing to do with x by equating coefficients. And by equating coefficients is just simply saying that the x squared on the left of the equation must be equal to x squared on the right of the equation, or the x's on the left is equal to the x's on the right. Then, now you've got your quadratic. So you ended up with something like x minus 2 times x squared plus 5x plus 8. Okay? With that quadratic, the first thing you're going to always try to do is, can I factorize it? Okay, so your first step, okay, will be to factorize. If it can be factorized, it means you've got rational solutions. So in other words, if you factorize the quadratic and you've got 2x minus 3, x plus 4, okay, then your answers would be x is equal to 3 over 2, or x is equal to negative 4. So you get, if you can factorize something, you're going to get rational numbers as solutions. So you're always going to try to factorize first. If you can factorize rational solutions, then you solve. Okay. Then if you can't factorize a quadratic, what do? You use the quadratic formula. Okay, and the quadratic formula is x is equal to minus b plus minus b squared minus 4ac over 2a. Okay, and if when you're solving that, you end up with a negative number, okay, underneath the third. Okay, then you're going to have, sorry, let's make sure you can see that. So if when you're solving this, okay, you use the quadratic formula. If that b squared minus 4ac turns out to be negative, that means you're going to have non-real solutions. In other words, you're going to have a complex solution, okay, and with a non-zero imaginary part. So there'll be an I in the solution. Okay, if however the answer is positive, if that thing is a positive number and it's a non-perfect square, like the number 5, then you'll end up with an irrational solution. So the steps are the same. Basically, what you're always going to try to do is once you get to the quadratic factor, to solve the quadratic, it's what you've done before in an AP. If you can't factorize, you use the quadratic formula, and you're going to get your solutions from there. Okay. Right, we're just going to do 2 quick examples, and then you're going to do an exercise by yourself. And the first example, okay, says solve for x is an element of complex numbers. That's important, okay, because if you're doing in core, you'd always solve for x as an element of real, and once you get a negative under the third, you'd stop. Okay, so you've got x cubed minus 9x plus 10 is equal to 0. You want to find which values of x satisfy that equation, in other words, give you an answer of 0. A good habit to get into is always name the equation. So we're going to call it, let f of x be equal to x cubed minus 9x plus 10 is equal to 0. And a possible solution will always come from the factors of 10. And the factors of 10 are plus minus, positive and negative factors of 10 are plus minus 1, plus minus 2, plus minus 5, plus minus 10. And there's no ways we're going to give you, hardly ever make you check more than one or two of those solutions. So I would always start from plus 1 or minus 1. So if you put in positive 1, you're going to get 1 plus 10, which is 11. 11 minus 9 is 2. That doesn't give you 0. We're only interested in something that gives you an answer of 0. If I put in minus 1, I'm going to get minus 1. Minus 9 times minus 1 is minus 9 times minus 1 is plus 9. Okay, so that's not going to work because you're going to get, let's just do it over here. F of minus 1 would be minus 1 plus 9 plus 10. Okay, which doesn't work. It's not equal to 0. Okay, what about 2? F of 2 would be 8 minus 18 plus 10, which is going to work. Okay, so you need to show that working for the one that works. So you're going to go f of 2 is equal to 2 cubed minus 9 times 2 plus 10, which is 18 minus 18 is 0, which in other words, 2 satisfies the solution. Okay. Because you sub in 2, you get an answer of 0. So 2 is one root, one x-intercept of the equation, so f of 2 is equal to 0. And if x is equal to 2 as an answer, is a solution of f of x is equal to 0, then x, therefore x minus 2 is a factor of f of x. Okay, so x minus 2 is a factor of f of x. So if x minus 2 is a factor of this whole thing over here, just remember I said if 3 is a factor of 15, there exists another number such that 3 times something is 15. Likewise with algebraic expressions, x minus 2 is a factor of f of x, so x minus 2 times something must give you f of x, which is x cubed minus 9x plus 10, and we know that's all equal to 0. Okay, so we're going to have x something x squared. To find the coefficient of x squared, we're just going to look at that. X times what is going to give you x cubed? X times x squared is x cubed. And to get the constant term at the end here, you're simply going to say to yourself, self minus 2 times what gives me 10, and minus 2 times minus 5 gives me 10. And then you admit defeat with the middle term and you say, I'm not quite sure what that's going to be. I'm going to call the unknown k. All right. Then to solve for k, you can go look at x squareds or x's. Let's pick x squareds. If I look at x squareds, x times x squared won't give me an x squared. X times kx will give me an x squared, so I write it down, kx squared. Minus 5x doesn't work. Minus 2x squared gives me an x squared. Minus 2kx won't. Minus 2 times minus 5 won't. So there are all the x squareds on the left, and they must be equal to the x squareds on the right. And there aren't any, so that must be equal to 0x squared. It's kind of rubbish math, but that's what we're talking about. So you're going to say basically k minus 2 must be equal to 0. So k must be equal to 2. Remember that you could have looked at it. The x's, if I'd looked at the x's, x times x squared is not an x, that's not an x. X times minus 5 is an x. So you get minus 5x. Here, minus 2x squared doesn't work. Minus 2kx does, so you get minus 2kx is equal to the x's over there, which is minus 9x. So you can drop the x's in this case, and you get minus 5 minus 2k is equal to minus 9. And we're going to end up with minus 5 plus 9 is equal to 2k. So 4 is equal to 2k. So k is equal to 2. Same answer. Up to you. Pick one or the other. Doesn't matter which one you pick. Right. So that's that over there. Okay. Now we need to finish off the solution. So now I've got this thing over here. f of x is equal to 0, but we know f of x can be factorized into, rewritten as x minus 2 times x squared, replace k with 2, okay, plus 2x minus 5. So I've got to solve that. So if two things times together give you 0, it means x minus 2 must be 0, or x squared plus 2x minus 5 must be 0. Okay? Two things times together give you 0. One of them must be 0. So therefore, x must be equal to 2 is one solution. And now I've got to try to solve x squared plus 2x minus 5. Well, you can't factorize that. And if you can't factorize a quadratic, we're going to use a quadratic formula. Okay, so we're going to say, and in this, a is equal to 1, b is equal to 2, c is equal to negative 5. And I'm going to be using x is equal to negative b plus minus the square root of b squared minus 4ac all over 2a. So x is going to be negative b, which is negative 2, plus minus the square root of b squared, which is 2 squared minus 4 times 1 times negative 5, all over 2 times a is 2 times 1. So x is equal to minus 2 plus minus, okay, 2 squared is 4. This is going to be minus 4 times minus 5. Be careful of that, is plus 20. So you get 4 plus 20, which is 24 over 2. Okay, if I've made any careless errors, please let me know. So I get x is equal to minus 4 plus, let me just double check, plus 20 is 24. How do I write that in simplest third form? Well, you can cheat and use your calculator, or you can just say x is going to be equal to, well, 24 is 4 times 6, okay, which is going to become x is equal to minus 2 plus minus, well, root 4 times, I'm going to show you the step I normally wouldn't, 4 times 6, as I say, use your calculator at this point if you want to. So I get x is equal to minus 2 plus minus, well, the square root of 4 is 2, so you get plus minus 2 root 6 over 2. And if I divide everything by 2, I'm not cross-cancelling, I'm saying minus 2 divided by 2 is minus 1. Plus minus